Okay, this is Pure 1 January 2023. I'm going through question 5 on this paper. So I would like to use, in this case, the following substitution to replace 3 to the power of x by p. And I would like to prove that this can be written in this form in here. So therefore, in order to do this, I'm going to use rules of indices. So I'm going to split 9 to the power of x in here, and I could write 9 as 3 to the power of 2. It's 9, and I'm going to write it 3 to the power of 2x. I'm also going to rewrite 3 to the power of x plus 2 using the rules of indices as 3 to the power of x multiplied by 3 to the power of 2, or I can still rewrite this 3 to the power of 2. It's 9 times 3 to the power of x. In the same way, I can rewrite 3 to the power of x minus 1 in here as 3 to the power of x multiplied by 3 to the power of minus 1. 3 to the power of minus 1 can be written as 1 over 3 to the positive 1 multiplied by 3 to the power of x. So if I'm going to use all of this and I'm going to split this and I'm going to rewrite it, I have therefore 3 times 9 to the x. I managed to write this down as 3 to the power of 2x, 3 to the power of 2x, and add 3 to the power of x plus 2. I have managed to rewrite this into this form, so I'm using that, and I'm using 9 multiplied by 3 to the power of x equal to 1 plus, now 3 to the power of x minus 1, I managed to rewrite it in this form, so therefore becomes as 1 over 3 here is multiplied by 3 to the power of x. Now I can use the substitution, so therefore I can replace 3 to the power of x by p, and therefore this will become p squared in here. So if I write it down, I have 3p squared plus 9p equal to 1 plus 1/3 multiplied by p. But because I do have a denominator, I would like to multiply everything by 3, get rid of any denominators. So you want to multiply every single term by 3. If I multiply the first term by 3, it will become 9p squared. I multiply the second term by 3, 9 times 3, 27p, equal to 1 times 3 is 3. And when I multiply this fraction, 1/3 multiplied by 3, it's going to be 1p, 1, which I do not need to write it down. Now, I do like to rearrange, so I'm going to minus 3 from both sides, and I'm going to minus p as well. So this will become now 9p squared. 27p minus p becomes add 26p, and I have minus 3, make this equal to 0. This is therefore what we needed to prove in part A. So this is section A, which we managed to prove. For section B, we would like to solve the following equation further. So I'm going to solve this, therefore I would like to start to factorize for part B. So I would like to find two numbers multiplied to be minus 27, and I need the same numbers when I add them to be 26. So my required numbers must be 26 minus 1, 26 minus 1. So therefore I'm going to split 26p into 27 times by minus 1 is minus 27, 27 minus 1 is 26. I'm going to split 26p into 27p and minus p, and I'm going to minus 3, and I'm going to copy down the first term, and I'm going to copy down the last term. If I'm going to factorize the first two terms, I'm going to take outside 3p, actually 9p here. Yeah, I can take outside 9p. It's going to leave us in a bracket with p plus 3. And I'm going to factorize the last two terms. I'm going to take out the factor of minus 1, will leave us with p plus 3 equal to 0. Now I can fully factorize this. Will give us 9p minus 1 as well as p plus 3 equal this to 0. So if I'm going to equal the first bracket to 0, I have 9p minus 1 equal to 0. If I rearrange, 9p is equal to 1. Value of p must be 1 over 9. This is the first value. Now if I equal to 0, the second bracket becomes p plus 3 equal to 0. Once I rearrange, this becomes p equal to minus 3. But I have used the substitution. I have used the following substitution where I have allowed 3 to the power of x to be equal to p. So therefore I do need to find the value of x. So if I will say, then therefore I've used the following substitution. So the value of p is 1 over 9. Now this can be rearranged as 3 to the power of x is equal to 1 over 3 squared, and can be rearranged further into 3 to the power of minus 2. Now I can ignore the base number and I can equal indices, so will become the value of x as equal to minus 2. It's the first value of x. Now for the second value of x, there are going to be no solutions for this because simply is a negative, so there are no solutions. So our only solution is x equal minus 2. Thank you.